welcome back to case 5. In case 5, we will be solving integral questions of this form. Now, we are not restricting f of x to be linear now. We are not saying f of x must be linear now. Now, we are saying anytime you have two functions multiplying each other, and even if one of them, this one has to have a power here, it can be a power of 1, it can be a power of 2, it can be a power of 3. Now, we are saying that if you have a function of this nature, that when you differentiate what is here, you will get this part. That what you just do is to write f of x raised to the power n plus 1 all over n plus 1, then plus your constant. Now you won't be dividing by f prime of x in this case because it is here and it has cancelled out already. So let's move to question 1. The integral of x bracket 5x squared plus 2 raised to the power 6 dx. Now when I differentiate this part, I will get 10x. But this is just x here. I have to do some little manipulation to bring out this 10x. What do? I multiply and divide by 10. So I'll just have 10x, I multiplied by 10, and I will also divide by 10. Then we have 5x squared plus 2 raised to the power 6 dx. Now when I differentiate this part, I will get this. So I strictly just use the formula f of x, which is just this, 5x squared plus 2 raised to the power 6 plus 1 all over 6 plus 1. But don't forget there is a 10 here, so I have times 10. So this is 5x squared plus 2 raised to the power 7 all over 70. And this will be our final answer. Now normally if you are asked to differentiate this, you have to just use chain rule, bring down this 7 to cancel out, then differentiate the inside, subtract 1 from it. It will give you back this. So whenever you see two things, if peradventure you differentiated this and you didn't get this, manipulate. If you cannot manipulate, just know that it could either lead you to integration by parts or integration by trigonometrical substitution, or it can lead you to something else, or it's not for your level or scheme. So basically, if it's not like this, if it's not in this form, let's say you differentiate this and you can't get this, and it cannot be manipulated to get this, is either it will lead you to integral by parts or another standard. So let's move to question 2. Question 2, we have integral of this. Now don't think of you have to consider the two functions. Don't consider this one because this one has square. But you can still consider that when you differentiate sec x, you will not get tan x. You get sec x tan x. And there's basically no way you can manipulate it. Let's come over to this function. When you differentiate tan x, you will get sec square x. So it means that this is the function that we are considering. And what is the power of this function? It is raised to power 1. So our final answers becomes tan x. Don't forget, you add 1 to the power, 1 plus 1 all over 1 plus 1 plus c. So this is tan square x all over 2. It's possible that it is tan cube x. When you differentiate tan x, you get sec square x. So this would have been 3 plus 1, 3 plus 1. So let's move over to question 3. Question 3. Now when you differentiate sin x, you will get cos x, not cos square x. And there's no way you can manipulate cos x. There's basically no way you can manipulate cos x so that it will suit your taste here. So let's consider this function. When you differentiate cos x, you will get sin x. So it means that we are using this function. So as usual, add 1 to the function, add 1 to the power plus 1 all over 2 plus 1. So this is cos cube x all over 3 plus c. Now that will be all for case 5. Case 5 hardly comes out, but that will be all for case 5. Let's move over to integration by parts. Welcome to case 6. Case 6 is under integral by parts. Now anytime your case 5, two functions are multiplying each other and you are told that if you differentiate one and it gives you the other function, you have to just use the formula I dropped. But this is not the case in integration by parts. If you differentiate exponential x, you will not get x. If you differentiate x, you will not get exponential x. So it means that that formula will not work for this kind of function. This is where integration by parts comes into place. Now when you are doing integration by parts, it comes from product rule, but because of time, I won't go through the process of explaining how this formula came about. I'll go through the shortcut and give you how to solve it. There's something called DI setup. DI setup. We are solving question 1, integral of exponential x dx. DI setup. What D means is differentiation. What I means is integration. Now you have to differentiate one and integrate the other one. But when choosing the one to differentiate, you have to be very smart. Now if I differentiate x, it reduces to 1. But when I differentiate exponential x, it will still give me exponential x. If I decide to integrate x, the power of x will eventually increase. So it is wiser to differentiate x and integrate the other one. When I differentiate x, I will have 1. When I integrate exponential x, I will have this. Put plus, minus. Supposing that this was x squared. If I differentiate it, I would have gotten 2x. If I differentiate again, I would have gotten 2. So I'll just put plus, minus, and so on. I'll continue in that form. But the question is x, not 2x. So we have x, 1, minus. Now, how you do it is, you cross them diagonally. Please, this will not go to this. Then this one goes to this. And then you differentiate and you got something like this. And so on. What you would have been doing is, this will go to this, this will go to this, this will go to this, and lastly, this one will go to this. Don't forget your plus, minus, and so on. So that's the pattern of arrangement. So don't forget, the original question is this. So integral of x exponential x dx will be equal to this times this, x times exponential x. Then this last part you are doing like this, you must always add integral to it. Minus sign is here. Integral of 1 times this exponential x dx. Now when I integrate exponential x, I will get exponential x. So no need for me to write that. I will just have this. Then don't forget to put your constant. This is the final answer. Exponential x is common here. I can leave my answer like this, or I'll bring exponential x out. So we have x minus 1 plus c. So that's the answer for the first question. Question 2, we have x squared cos x. Now how do I go about this? Same procedure. I will differentiate the x squared and integrate cos x. When I differentiate this, I will get 2x. When I integrate this, I will get sin x. Now when I now do the normal, this goes to this, it will also lead me to integration by parts. So what I will do, I will just continue so that I can reduce x completely. When I differentiate this, I will get 2. When I integrate this, I will get minus cos x. Minus cos x. So this goes to this goes to this, and lastly this one goes to this. We have plus, minus, plus. So the original question, exponential x squared cos x dx, don't always forget this, is equal to x squared times sin x. But there's a minus sign here, this times this, minus times minus is plus. So we have plus 2x cos x. Then I told you the last part, you must always add integral. But there's minus times plus, which is minus 2 times this, 2 cos x plus c. Now when I integrate 2 cos x, I'll get 2 sin x. So we have x squared sin x plus 2x cos x minus 2 sin x plus c. So that will be the answer for question 2. Now let's move to question 4 before I do question 3. Question 4, we have integral of ln x dx. Now, two things are not multiplying each other. But do you know that For every x I have, I can write it as 1 times x. So instead of writing it as ln x, I can write it as 1 times ln x. Now, two things are multiplying each other. So we carry out integration by parts. But the question is, which do we integrate? We can't integrate ln x because the original question is to integrate ln x. So we rather differentiate ln x and integrate 1. So when I differentiate ln x, I will have 1 over x. When I integrate x, I will have x plus and minus. Now this goes to this and this goes to this. So it's x times x times ln x. Then I told you the last part is always integral. Minus times plus is minus. 1 over x times x dx. This x can cancel out. So we have integral of 1. When you integrate 1, you get x. So when I integrate 1, I get x. So this becomes plus your constant. You can leave your answer like this, or you can bring x out so that you have ln x minus 1 plus c. So this becomes the final answer for question 4. Now let's move over to the last question, which is question 3, quickly. Now whenever you see exponential x times cos x or exponential x times sin x, it will lead you to, should I use the word reoccurring? It will always reoccur, because when you differentiate sin, you get cos. When you differentiate cos, you get minus sin. You'll be getting cos and sin. But follow this procedure carefully. For question 3 di, I want to differentiate exponential x and integrate cos x. Now when I differentiate this, I will have exponential x. When I integrate this, I will have sin x. When I differentiate this, I will have exponential x. When I integrate this, I will have minus cos x. Eventually, when I continue, I'll keep on getting cos sin, exponential x, and so on. So I would rather just stop at where I got cos x back again. Now, as usual, follow the normal procedure. This goes to this, this goes to this, and the last part is done this way. Plus, minus, plus. So the original question, exponential x cos x dx is equal to exponential x times sin x. Then we have minus cos x times minus exponential x, which becomes plus exponential x cos x. Then the last part, I told you it has to be integral. Plus times minus. We have minus integral of exponential x cos x dx. Now, what do you observe about these two things? This is the original question. This is the original question. So let's call it A. Let's call it A. So we have A is equals to exponential x sin x plus exponential x cos x minus A. Now when I take this A to the other side, it becomes positive. So I have plus A plus A. So A plus A is 2A. And A becomes, exponential x is common to both sides. I will have sin x plus cos x divided by 2. So now what is our A? It's the original question. So we have integral of exponential x cos x dx. So this becomes our final answer. So that will be all for case 6. Let's move over to the next one.